everyone. Welcome class. I appreciate your continuation and your patience and having me in your lessons. Today we are going to complete chapter the state of matter, where we would like to talk about mixture to complete the picture of mixtures. And as you know, your curriculum has 4 topics for core students and additional 2 topics for the supplements all extended. State the distinguishing properties of solids, liquids, and gases. Describe the structures of solids, liquids, and gases in terms of particle separation, arrangement, and motion. Describe change of state in terms of melting, boiling, evaporating, freezing, and condensing. And the last but not least for the core students is to describe the effects of temperature and pressure on the volume of a gas. Additional 2 topics are being published for the supplement students to explain change of states in terms of kinetic particle theory, including the interpretation of heating and cooling curves. Explain the term in terms of kinetic particle theory, the effect of temperature and pressure on a volume of a gas. This is actually our curriculum for the first chapter, and let us proceed. Now, as I mentioned before, this is a completion of the mixture and the mixture properties. Mixtures of substances in different and diffusion. So we have some terms we would like to go through in order to revise the previous ones and at the same time expand our knowledge about them. A mixture, what does a mixture means? It is a mixture or a blend of 2 or more substances, blend but not chemically combined. The substances can be separated by physical means. So this is the definition of a mixture. A solution is a type of mixture or blend. Substance is a substance is formed when a substance which is a solute dissolve into another substance which is a solvent. So what is the solute? The solute substance that is the solid substance that has dissolved in a liquid, which is a solvent, to form a solution. Fourth term, which is very important, what is a solvent? A solvent is the liquid that dissolves the solute to form a solution. Example, water, organic solvents. A suspension, it is a type of mixture of blend containing small particles and of an insoluble solid or droplets of insoluble liquid. Spread means suspended throughout a liquid. So those are 5 important terms, and we have more for this in order to complete our chapter 1. The second group of terms start with the following. Precipitation, a precipitation reaction. What does a precipitation reaction means? A reaction, it is a reaction in which an insoluble salt is prepared from a solution of 2 soluble salts. What is soluble? Soluble is a solute that dissolves in a particular solvent. Insoluble are substances that does not dissolve in a particular solvent. Admissible, it is a uniform solution made of a mixture or a blend of two liquids. So when we have two liquids that have been blended together, they are called miscible. Alloys, mixtures of elements, usually metals, designed to have the properties useful for a particular purpose. Example, older, an alloy of tin and lead, or gold 18 carats or 14 carats, has low melting point. Our third group of terms started with the, yes, you are right, saturated solution. It is a solution that contains as much solute as possible at a particular temperature. Very important, a particular temperature. Concentration, a measure of how much solute is dissolved in a solvent to make a solution. Solution can be diluted with a high proportion of solvent or concentrated with a high proportion of solute. Be careful. Here, what I did say is that solution can be dilute, a dilute, with a high proportion of solvent. So when I add solvent, I'm going to dilute the solution. While when I add the solute, not the solvent, I'm going to concentrate the solution. Solubility, a measure of how much solute is dissolved in a solvent at a particular temperature. Again, particular temperature, because they vary. If I start to stir, you see, mix sugar and water in room temperature, it's going to take some amount and then you cannot add more. However, you can add more if you raise the temperature. So be careful. Changing of temperature has a great effect on solubility. The process of which diffusion, the process of which different fluids mix as a result of the diffusion of their particles or the movement of their particles. Now let us go. Now here we would like to compare two things together: the solubility of solids in liquids and the solubility of gases in liquid, and see if there is any difference between them. Okay, so if we go for solubility of solids in liquids, concentrate solution. When you add solid, you are going to concentrate solution. Or when you are going to add the liquid, you are going to dilute the solution. Solubility of most solids increases with the increase of temperature and vice versa. So this is a direct proportional a process where the solubility of solids increases by the increase of temperature. A direct relationship. Both they are going in the same direction. However, it is different in case of gases. Solubility of gases decreases with the increase of temperature and vice versa. So if I increase the temperature and I would like to make this gas soluble, no, it's not. It's going to be insoluble, because what is going to happen is that the solubility of the gas is going to decrease by increasing the temperature. If I would like to increase the solubility of gas, I have to cool it to decrease the temperature. Solubility of gases increases by the increase of pressure and vice versa. Now here, take care of this, that the solubility of gases increases by the increase of pressure and vice versa. And this is why, this is because the pressure decrease the volume. So it's going to be more soluble. So be careful about the differences between the two. Now here we would like to see how something, we would like to see how diffusion of fluids take place, and also diffusion of gases based on the kinetic particle theory. Now, if we go for fluids, that means liquid, particles move from a region of higher concentration to the region of lower concentration. The particles are evenly spread with the same concentration. Be careful about what I am saying. This is very important here. The particles move from the region of higher concentration to the region of lower concentration. That means the particles are evenly spread, and that means distributed with the same concentration. The rate of diffusion in liquids is much slower than gases. So if we compare liquid to gases and compare the diffusion of the liquids to gases diffusion, we are going to see that the rate of diffusion of liquids is more slower, or much slower than that of the gases. Diffusion does not take place in solids, as the particles cannot move from place to place. So be careful about this. Diffusion through solids, if you get two solids together, they are not going to diffuse through each other. Why? Because there is no way of movement for the solid particles in order to move. So be careful about this point. Now, if we are talking about the diffusion of gases based on the kinetic particle theory, that heavier gases or heavier gas particle move more slowly than higher particle at the same temperature. I mean lighter particle at the same temperature. Large molecules diffuses more slowly than smaller ones. So be careful. The weight or the heaviness of the gas particle affect the diffusion rate of the particles, and also the size of the molecule will also affect the rate of diffusion. And both of them, they will be affected inversely. If you increase the weight of the particle, then the diffusion is going to be less. If you increase the size of the particle, the diffusion rate is going to be less. The rate of diffusion is inversely related to the mass of the particle. The average speed of the particles increases with the increase of temperature. Now, when we add temperature here, temperature always makes the particles more free, especially in gases. So when they make it, three things are going to happen. First, when you add temperature, you add energy. So you add energy for the kinetic power for the or energy of the particle, you add it. Then you add space between the adjacent two particles. When you add the space between the two particles, if I have a particle here and I have a particle here, and I increase the space between them or the distance between them, then the electromagnetic or the attraction force is going to weak, and this make the particles move very freely and very quickly. So be careful about these four things. Now we come to our end part. We finish our first chapter, state of matter. The only thing left is going to be the next episode, which is episode number 6, where I'm going to teach you the experimental part of chapter 1. It might be late. I'm going also to start chapter 5 because some of the students asked me about that. So I'm going to start with. And actually, I'm going to start with the end of chapter 4. Until then, let us talk more. The only thing left for chapter 1 is the practical part, and I'm going to do it next class. Bye-bye. Have a good one. I appreciate your patience. Thank you for having me. Bye-bye.